Okay, so Alexandra Nesic is a PhD in materials engineering with a background in pharmaceutical engineering. She works as a research associate in the Department of Materials Engineering, Faculty of Technology of the University of Novi Sad, Serbia. She's working on biobased and biodegradable polymers with the idea of creating more circular and sustainable solutions. Currently, her research is focused on developing electrospun polymer-based materials for potential applications in cosmetics, biomedicine, active packaging, sensors and filters, and so on.
So good afternoon, everybody. My name is Alexandra Nesic, and today I will present you just a small part of the results that were obtained during my STSM at Faculty of Polymer Technology in Sloven Gradec in Slovenia. Within the cost action circulability, I will just shortly speak about some thermo-mechanical properties of recycled PLA. I think that all of us know the PLA and why the PLA is very popular among the scientists and also the industry. It's the biopolyester with very, let's say, it is produced in a large scale, and the price is almost the same like fossil-based polymers. So it can be competitive to those polymers. And it can be used for production of various, the range of different plastic products. It became promising change for fossil-based polymers, especially for single-use plastics. Because we all are facing the global problem of single-use plastic packaging all over the world, beaches and so on. So the idea was to change those with some biodegradable, and PLA was the first, the polymer of choice for that application. What is the challenge with the PLA? The main challenge is biodegradability in different environments. So it's not like you have for example, fork from PLA and you throw it away and it will degrade in, I don't know, if you put it in landfill or in seawater, it will degrade with the same rate of degradability, or it will degrade at all. Because there is a big difference, and it is concluded that the best way for the biodegradation of PLA is actually to be composted in industrial scale composters, so under controlled conditions. The second question is the biodegradation actually the best end of life? So do we want to waste all of the sources, raw materials, energy, water, and so on that we invested in production of this material just to let it go away when it degrades once? And that's something that we want to check if is there a possibility and how many times it is possible to recycle PLA. So we obtained PLA bottles, like you can see on the pictures. So those are PLA bottles that are industrial waste, meaning that the shape or the thickness of the bottles or something is wrong. So if they're from production, they are never used. Actually, they're never been packed. The products are never been packed inside, and we obtained them from Slovenian company Stramex PET. The first step was to mill them, so to mill the bottles. Then we extruded that PLA, and after that the material undergoes 10 cycles of injection, molding, and milling. So once we injection molded or prepare the samples, we take one series of 30 samples for the examination, and the rest we are milling, so we are repeating the process all over again by 10 times. These are the samples. The reason why we were using injection molding instead of, for example, extrusion, which is maybe the most common processing technique for the PLA, is just to prepare these standardized samples. That's why we were using injection molding. These are just few characterizations that we have done. So melt flow rate, tensile test, DSC, and TGA that I will present. We've done many more. And all of these characterizations were done at Faculty of Technology of Polymer Technology at Sloven Gradec. So first, the melt flow rate. We were comparing all 10 cycles of injection molding, also with just milled bottles and extruded ones. So as you can see, except this first cycle of injection molding, which we cannot explain why, but all of them are actually rising. So as expected, due to some reprocessing and consecutive processing of material, there is some degradation that is occurring, and the material, the chain length is decreasing. So the melt flow rate is increasing in that situation, but the increase is not so high. So if you consider all the cycles, so there are actually 11 thermal processing cycles. The melt flow rate rises, 50 or 60%. When we tested the mechanical properties, we also have the tests for all of them, I mean for all 10 cycles, but the results are very similar. So we took just first, fifth, and 10th cycle of injection molded samples. As you can see, the maximum stress is, and the break strain in percent is in the actually in the range. So maybe the difference is 10%, and there is no, let's say, significant difference between the mechanical properties of first cycle samples and 10th cycle samples. These are the results of the differential scanning calorimetry, the first heating. So here the first thermogram is for milled bottles. As you can see, as they're transparent, there is no cold crystallization, but when compared the melting points and the glass transition temperatures, we can see that the difference is very low, just 1 or 2 Celsius degrees. So the thermal properties of the materials in first heating are not are not significantly different. When we cool the samples and heat them again, we got actually more consistent situation. So the glass transition temperature is almost the same as also are the crystallizations and melting points. We are now waiting for the results from the crystallization experiments from XRD. We want to check the crystallization rate of the samples, because we assume that this crystallization is actually one part is okay from the PLA, and another part might come from the pseudocrystals that are formed with around the molecules that with the shorter chain lengths. So they have the role as nucleating agents for PLA. So it might happen, but we are still trying to find out why the thermal properties are the same actually for all 10 cycles. But what we can see from TGA analysis, if we compare the green one, which is the milled bottles, and the blue one, which is the 10th cycle of injection molding, we can see that with the higher cycle of injection molding, the degradation temperature actually decreases. So the degradation is from 369 to 363. So there is around 6 degrees of decrease in the degradation temperature within the, or when compared the milk bottles and the 10th cycle. That is also expected because we taking into consideration that, okay, injection molding, during the injection molding and this reprocessing of the material, there is some degradation actually of the material that occurred. As far as we analyze all the results, we can say that thermal and mechanical properties of the PLA are not affected by multiple processing. So both thermal and mechanical injection molding and milling. And PLA can be recycled at least 10 times. So we went up to 10 times of reprocessing. We don't know what will happen after that. Also, what we didn't know here is which modifiers are used for the PLA before the production of the bottles. So we don't know what is actually inside, which additives. Maybe they are also helping this kind of processes and improving the recyclability. And what we did, we didn't add any new additives or any virgin PLA. So these are just 10 times of the same material. At the end, I would like to thank Stramex PET company, which provided the PLA bottles, and the cost action circulability, which enabled this work and the results, and also some other projects, and also the colleagues from Slovenia, which gave the big support to this work. I would like to thank you for your attention. I was very short. Hope that you, if you have any questions, I'm here to answer.
Thank you very much, Alexandra, for your presentation. Are there any questions?
I want only to know if you before your test, extrusion and injection molding, you followed the same residence time in the extrusion process and the same heating treatment, pre-treatment of the grains before the injection molding.
Actually, yes. After each cycle of injection molding plus milling of those samples, we put the material to dry at the same temperature for the same amount of time, and then we repeat the whole process. So basically, all 10 times the procedure was the same.
Okay. Yes, I congratulate with you for your work. Because I think also that a thermoplastic material could be in its best processing condition to be transformed a very big lot of times without any substantial modification. Thank you.
Thank you.
Thank you. Very nice talk. I wanted to ask you if you have seen some differences in transparency or barrier properties after the cycles.
Yeah, we also measured that. I didn't show those results, but with your own eye, you could see the difference in color. So the first samples were, let's say, just transparent, and the color was kind of yellowish. But the last batch was slightly brownish and the slightly opaque, so the transparency was not so good. But yes, from the first to the 10th of cycle, yes, there is a difference in color.
Thank you. And barrier properties? Permeability to oxygen or something like this?
We didn't check that. We just focused on
mechanical properties.
Yes.
Thank you.
Thank you.
Alexander, thank you. I want to make a comment because in the BioNTop project that is ongoing, we are making similar experiments onto pure PLA, but after production of film for extrusion casting. So the results are quite similar, and it seems that the multiple injection molding of these pure PLA samples behave in a similar manner. So I agree fully with you that it can be recycled many times. Okay,
thank you. Thank you. But I think that maybe if we do the multiple processing of, for example, with extrusion, because of the shear, maybe the degradation will occur faster. So maybe we could, for example, recycle it 5-7 times, but with injection molding, it is possible to do it more than 10 times. Thank you.
Okay. Any questions? So, I have just a question. So, you have shown that it's feasible to recycle PLA up to 10 times. But I think the problem is the separate collection of PLA-based products. What do you think about this issue? If it's an issue.
Yes, actually that is the big issue, that we are not, I think on global level, we are not actually separating the fossil-based materials in the right way, so PLA should be separate from all of these. But we also have done some tests on compounding of PLA and PET. So maybe there can be a possibility to combine those two polyesters and to recycle them together, maybe. But we are still we are doing the examination of the samples. So we are finding the best, let's say, the best performance and the best results and best properties for the best ratio of the PLA and PET.
Thank you.
Thank you.
Thank you. Thank you. Okay, I'm going to the last presentation.